Okay, so here's differential equation. The height h in meters of a shrub t years after planting is given by this differential equation. A shrub is planted when its height is 1 meters. So that means basically when t was 0, that's when it's first planted. So firstly, we're going to show by integration that t equals 20 ln of 5 over 6 minus h. Right, so first step. Let's separate our variables. Okay, so we've got dh over dt equals 6 minus h over 20. Okay, well, the h is on top. So we'll take the h to the left and we'll multiply through by the dt. So that means that I need to get this term with h in it, this side. So I'm going to divide by 6 minus h. So I have 1 over 6 minus h h. I'm going to multiply by dt, which means I'm going to have 1 over 20 dt. Okay, once I've done that, now I'm going to integrate. Integral of 1 over 6 minus h dh, and that's equal to the integral of 1 over 20 dt. And that's going to give me, basically 1 over something is going to give me log normal of the denominator. The only thing I have to remember is if there is a coefficient, in this case, because it's a negative number, that coefficient is -1, I have to divide by the coefficient. So that's going to be minus log normal of 6 minus h. Okay, and 1 over 20, well, that's easy enough. That's just going to be 1 over 20 t, because we're integrating by t. And remember to put in my constant, because it's not a definite integral, as there are no limits given. Okay, so now that's good. They've given me an example, which is when it's planted and t is 0 and height is 1. So now I need to try and work out, I need to find c. So I'm going to use the example I'm given. T equals 0 and h equals 1. So what I'm going to do, I'm going to make this equal to c. So I'm going to multiply everything by, I'm going to basically take this over here. Okay, so what I'm going to do, I'm going to multiply by 20. So I've got negative 20 log normal of 6 minus h equals t plus something that I don't know. Okay, well, t is 0. So let's subtract it to make this c the subject. So I've got minus 20 log normal of 6 minus h minus t equals c. Right. Well, t is 0. So we can just cross that out. That's going to give us nothing. And h is 1. So that means that we've got minus 20 log normal of 5 c. So now we've found our constant. So now what we do, we rewrite. Okay, so that means that now I've got that, and I've got minus log normal of 6 minus h equals t minus, is equal to t minus 20 logs of log 5. Okay, because that's my c. Remember, this is c. Right. So now I want to rearrange this to be equal to t, because that's what the question is asking me to do. So I rewrite that as, I'm going to add this. So I've got 20 log normal 5 minus 20 log normal 6 minus h. And that's equal to t. We can combine our logs. We've got the same coefficient. So it's 20 log normal of 5 over 6 minus h equals t. Right, so that's the first part taken care of. How long after planting the shrub reach a height of 2 meters? Okay, well, the height is 2 meters. That means we know what this is. We know h is. So all we have to do here is substitute in h equals 2. So we know that time is equal to 20 log normal of 5 over 6 minus h. And this question, h we said is 2. Okay, which is 20 log normal of 5 and 4, which usual calculators, you get 4.462871. Round up through 6 gigs, and that is part 2 taken care of. Part 3, find the height of the shrub 10 years after planting. Okay, so again, this time we're given that t equals 10. So that means that now 10 is equal to 20 log normal 5 over 6 minus h, and it's h that we want this time. So let's divide by the 20. So that means that 1/2 is equal to log normal of 5 over 6 minus h. Now we can raise this to the power of e, which means that e to the half is equal to 5 over 6 minus h. Okay, then we just need to do a bit of manipulation, and we get that 6 times e to the half minus 5 over e to the half equals h. And again, for our calculators, that's 2.96734467. And that's the third part taken care of. Now the last part. State the maximum possible height of the shrub. Well, to do that, all we need to do is think about our equation. We know that t is equal to 20 log normal of 5 over 6 minus h that we've been using since part A. And if we look at the denominator, 6 minus h, if h is greater or equal to 6, that's going to be a negative number. Okay, and we know that we can't take the log of a negative number, so the maximum is 6. Okay, it can be 5.99, 5.999999, whatever it is, but it can't be 6. So that we put the maximum height as 6 meters. Easy.